Hello there, I'm back again, Saif Jawad here for you, and this time we're going to do a new segment about testing. This time we're going to talk about test integration or integration testing, however you want to turn it around. I mean, still mean the same, and that is going to switch to another screen here. So yeah, integration testing code or Java integration testing. The level is meteor, so you need to have already done some unit testing and some other kind of testing. So you would do the integration testing because they are related but a bit different, and I will go into the differences in a bit. Yeah. So the intended audience. The intended audience is, as usual, software developers, anyone interested in... Oh, wait, I'm going to remove my face from the screen so you can read, actually. So software developers, anyone interested in testing code, and the level is meteor. And so, yeah, I'm not going to make a very big introduction. If you have seen the previous video, then unit testing is about testing one unit, about one block of code, one class or one method or one function, one component or one module. In this case, testing, integration testing is are multiple parts that are moving together, that are connected together, that can influence each other, and that's when you want to the end result of all that interaction to be something desirable. As you can see here with Pat and Matt, he's pushing on one place, pushing on the other place. They all move because they interact with each other. And that's actually what integration testing is. You test multiple parts to see if they work together well in the way that you would expect, and keep working together in the way you expected them to do the next time a code change has happened. So yeah, let's go to the developer mode. And I created a little REST endpoint because this is a very nice integrated parts working together. See, the Spring Boot is a container that has many features. I'm using one of the features today, which is the MVC, Model View Controller part, and to make a two endpoints in this case. So these endpoints, one of them generate a number. It's a special number. It's an 11 proof number. I have made some videos about the 11 proof, and if you're really interested in it, you can watch. You can download the code and see what it does, and read the README file. It's down in the same project that I have prepared for you as for the example code. And basically what it does, like bank numbers in the Netherlands, or the social security numbers that we use, are 11 proof. What that means is you have the number of your social security or bank number, bank account number, and you have some multipliers that are defined for that specific type of numbers. For the bank is using a different type or a different weights, and the social security numbers using a different weights. In this case, I'm using the social security numbers, and then you multiply them all together and then total them up and see if they get a if they are divisible, if the total is divisible by 11. Interesting, very nice. Nobody cares in the rest of the world because who uses 11 proof, right? Anyhow, in this case, we want to see how everything interacts together, because we have a controller that serves the endpoints we have talked about, and I'm gonna make it a bit bigger. So this is the controller. It generates, it has an API for the BSN burger service number, which is burger is a citizen in Dutch, burger service number, and it generates or either validates a number. So these are REST endpoints, right? When you are using REST endpoints, you can test them in quite a few ways. And when I'm saying integration is I want to see if Spring Boot is integrated well with the implementation that I have created with the controller. And also I would like to exclude one part, which is the DTO service. So the service that can handle these kind of numbers, and I would like to control its behavior, so I can test only the Spring Boot, spin up, and the controller. So how do we go about this? We can completely test the whole system from the controller all the way to the service and the Spring Boot by hand. You could call that an integration test. You'd be wasting a lot of time. I'll show you why. Let's see if I can switch. Yeah. And exit. So you can spin up the application and go and test. Generate a number. Let's generate a number. Generating a number is easy. Quick. Up. It's generated. And because we already generated it, it's 11 proof. So it's a null. Now, if we take this number that we have just generated and we want to validate it, if it's a validated, it's a valid number, we validate it. So put the number here. Tell our control to test it. Yeah, it's tested. So it's saying, okay, this number is 11 proof. We have just tested it. Wonderful. We made some great code here, but this is time consuming. And if a developer or a tester or a human being is going to be interested with the task of clicking, well, I can guess that this person is not going to be happy for a very long time because it's boring. It's very, very boring, and waiting until a developer comes up with a change and then you have to click on the test to see if it didn't break. Well, that's nonsensical. That's why we have automated tests, and I created one, and I am using a framework called RestAssured, which is RestAssured. In this case, I'm gonna take it here. Well, it spins up Spring Boot in this instant, and we mock the service. If you have seen the previous unit testing video clip, then you know that mocking means you create a fake object and you control its behavior. So it behaves in a way that you can control and make the rest of the application behave in the way that you would like. And we did two things. So what does RestAssured do? It starts up the application, gives it in this case with the WebMVC testing component from Spring Boot. They interact together to get a fake setup of the server and port, etc. So they can test the controller. And this is the controller that we are going to test. As we have seen before, let's go back. So, okay, so what are we going to do? So before, we are going to tell our mock object, which is the service that we have mocked before, the mocked bean. Listen, whenever it's called upon you to generate a number, then return a mocked response, a fake response. So this fake response, we figured out ourselves, we just make it, it's not true, it's not really valid or invalid, it's just a number that we know we gave it, so we can control and test that we receive what we have instructed it to give. So in this case, we tell, okay, go to this endpoint. Well, if you have seen the Swagger page before and the controller before, then you can see, all right, so this is API/BSN and then /generate. So that puts them together and you get this address, this URI. So we tell RestAssured, given that we accept this type of media as a return type, when we call upon this endpoint, then we expect we expect to get a status 200. That means it went well. HTTP 200, it's okay, means it's okay. And it has a body that contains a number that equals 1, 2, 3, 4 through 9. So if you do this, this will actually prove that Spring started up correctly. The context loaded, the containerized framework of Spring Boot is loading up your application. It's also loading up your controller class, and it is calling upon a dependency that it has called service and generate. Now let's try it and see if it does. And under here we can see test has passed. Everything is fine. It did what we expected. It returned like this. Okay, so you're thinking like, yeah, right, I'm gonna believe your nice brown eyes that this works. So I'm gonna show you that it works and how it works, because we already did a few mocking things and we are testing this class. So we can debug inside to see if it's actually going to come here. I'm gonna put a breakpoint and see if it actually passes here, right? And see actually what this mocked bean, so this mocked object, is going to generate the number that we expect when we call upon it. Let's do it. I'm gonna click on the debug button and see if it does what we want it to do. So debug. 1, 2, 3, spinning up Tomcat, Spring Boot spinning all night. It came here. Nice. So it did enter this endpoint and it is sound, and we came here. So if I'm going to look at this specific object, you can see here in the debugging console that it is a mocking object from Mockito. It's not the real one, it's a mocked object. So let's see if this mocked object is going to behave as we instructed to, and when we call upon it to generate, it's going to give us a number. And this number is going to be 1, 2, 3, 4, 5 through 9. Let's evaluate this. And I thought, evaluate. And what do you know? It's doing exactly what we wanted it to do, which is a controlled environment. We see what it's doing. So everything is behaving normally, and now you're thinking, oh, right. So couldn't I have done this with a unit test? Sure, this is the type of a unit test, but it's putting more things together, like spinning up the context of Spring Boot. Now, what happens if we mess it up? Like there's one dependency missing from auto wiring. Let's simulate that too. So, instead of mocking this bean, we're not going to give it this dependency. So the Spring, if it's going to start up, it's going to be missing a dependency. So I'm going to take it out. And then, of course, this part won't work because, of course, it is depending on us to... I'm gonna... Totally nonsensical, but let's see if it works. I know already that it's going to break because one dependency is not met for Spring, and this is harder to do with unit testing. And it broke. So why did it break? Because error creating a bean with a name because unsatisfied dependency expressed through constructor parameter 0. So if we look at that class, parameter 0, it's first dependency. It has only one dependency, and that's this service that we are not providing anymore. So great. This is nice. I'm going to go back to the test, undo all the damage I did, and then we try to break it in a different way to see that the integration is actually working, right? Let's see, right. So we are testing this endpoint. That's where our test is excelling. Also here we are doing the testing of the validation. So in a future context where a new developer, young and very eager, and has a very cool set of new slang language, and he thinks validate is a word used by grandpas and dinosaurs. So he's going to change it. So he goes to the controller and said, it's no longer called validate, it's called check. Of course, the syntax is good. And what he does next is test his work. So he goes on and he clicks on play. Oh, sorry, he doesn't click on play. He goes and starts up the application, the good developer that he is, to see if his work still works, if his changes still work. So he starts it up, and yeah, no, the application starts perfectly, it's fine. And then he goes to the Swagger interface to check his wonderful work. And look at this. It's no longer called BSN validate, it's called BSN check number. And even better than that, if we generate a valid number, we take it from here and we check it. We're gonna check it. Put it here, check it, say execute. It checks out. It is 11 proof. It checked it and it's checked. Good. But one problem there. See, your integration tests that we have created here is going to tell you that you are wrong and you did something horrible and bad. Let's go there. I'm gonna run the tests. Wait a bit. And I'm going to take a sip from my juice. Aha! See? This test is falling. It's saying it's wrong. So imagine if this is a small change, right? Functionally, it still works. But this eager young developer that knows much better than you and I how things should be called, changed it and it's fine. The problem is he's breaking a contract. If this is a contract that is like an OpenAI contract and a lot of other services are calling to this endpoint, they will break too. That's where your testing comes in. When you're testing and integration testing for in this area, you're doing it even if he did change the unit testing for his class, it wouldn't have mattered that much. The application will still work and everything will be fine. And this is just level 1 of integration testing. There's a bit higher level integration testing that is being done in the pipeline. So even if you change everything, there are still these checks are in place and are going to be checked. So they help you think twice, 3 times about the changes you made in the code. If they are valid and these tests are failing, then you need to change the tests, of course. Tests are just code that you can change as well. But there are agreements between you and the end users of your endpoints and have to be upheld, and this test will help you uphold them. Because, and again, the mapping functionality and the mapping here and the API REST interface mapping in general is not something that you can test easily with unit testing because it's done runtime. That means the application has to be started and some magic will happen under the hood by Spring, and then they will be executed and tested. This way, with integration testing, that you can actually call to the endpoint of a in this case it's an endpoint and we are using REST, but it might as well be for Kafka. But this will help you to ensure that your contracts and the working of your application is doing what it's supposed to do. Well, this is fun. I'm going to fix it because it's definitely should definitely not say check. My syntax is much better. It's validated. And yeah, run the tests again. Should run fine. All tests are good. Let's do a build for the fun of it as well. Where is my application? Lifecycle. Clean. Install. Run. Everything is running smoothly. And even that test ran. See that? See that? See springing up? That's us. And it's a successful build. Not to keep the video too long, and just keep it until here. I'm going to make this code available to you, and some refactoring, and continue, commit and push. And if you're interested in it and you want to go and grab this code and play with it and see the example, just go to my GitHub, and then save Jawad, and you will find the 11 proof REST API here, and that's the one that you should pull and play around with. And next time I'm going to show you something that's already in here, but it's a different matter because we're going to talk about Kubernetes and running these integration tests in a completely independent environment. That's what you are going to do with your application. Finally, of course, when you deploy to production, you no longer are fiddling around with it. It's no longer on your machine, it's somewhere else. So it's nice to have actually testing that can do these integration tests as well, independently in the pipeline, and test a whole wide variety of tests using behavior-driven development languages like Gherkin and Cucumber. But we'll get there next time. For now, thank you very much. If you liked the video, please give me that feedback. And if you didn't like it and I can change something, give me that feedback too. I appreciate any kind of feedback you give me. A like is always welcome as well. And thank you, and hope to see you next time.